Hello everyone and welcome to my channel Octopus Math by Sahiba. Right, so moving on to question 7. All right. So I think I should transfer this to a different software where I can easily draw. Right, so I have transferred this question to somewhere else, so it will be easier for me to draw lines in the graphs. Okay, so the function is this, and first we need to complete the table. So for the values of y, I need to substitute in the values of x. So first one is -3 because this is missing, and the second one is 5. So I'm just gonna put it, y is equal to 3 plus, instead of x, I'm gonna write -3 minus. Okay, so let me quickly erase everything. We have to take more positive axis of, more positive x-axis and less negative x-axis. And here we have a balanced y-axis. So that means the positive region of y-axis and the negative region of y-axis has to be equally distant. That means this x-axis has to be right in the center. So I'm just picking up a point. This is right. So for uh, equally distributed y coordinates, limits for y, we need to have x axis right in the middle of the graph. So what I did here is that I've distributed these small boxes in groups of 5 because the lines were not really visible. This line here, I believe, should be the center. So I'm drawing this line for the x-axis for equally distributed on the y-axis, right? And because we need more x-axis, more positive x-axis than the negative x-axis, we need to follow the scale as well. So 2 centimeter is equal to, okay, we need to follow the scale. It says 2 centimeter is equal to 1 unit. All right. So if I write 5 here, here, this I'm using these points as reference. If I write 5 here, this should be 4, 3, 2, 1, 0. And because this is 0, I'm just trying to count for the other 3 points. That because our x-axis is going up to -3. So if this is 0, this has to be 1, 2, and 3. Yeah, so we are done. So it's not always necessary to draw your origin right in the center, but because we have been given this, we need to follow and decide where our origin is going to be. Right, so following the scale, I've drawn this graph grid here, and I'm just going to plot the points. Let me use a different color here so it's visible. Right, for -3 and -4.5, so this is -3 on my x-axis and -4.5, so it should be between here. Right, okay. And then -2 and -1. So -2 on the x-axis and -1 on the y-axis should be somewhere around here. Okay, and then -1 and positive 1.5. So this is -1 and this is +1. This is +2. So this is positive 1.5 should be somewhere between these two. Okay, and then 0, 3. So 0 on the x-axis and 3 on the y-axis. 1, 3.5. So x-axis 1 and then 3.5 should be somewhere around here between 3 and 4. And then 2 and 3. So 2 and 3. So this is 2 and this is 3, right? 3 and 1.5. 1.5 should be somewhere around this between 1 and 2. 4 and -1. This is 4 on the x-axis. Again, this is -1 on the y-axis. 5 and -4.5 should be somewhere around here. Now I'm going to use the same color, red, and draw a smooth curve around the points. It's going to be a freehand drawing. We don't have to use a ruler. So I've connected the points in a smooth curve. It doesn't have to be accurate. Okay, so now that we have completed the table and drawn the graph, let's move on. And I'll be switching the windows for, I'll be switching the tabs to get the answers to the other parts. Okay, so part 3 says by drawing a tangent, estimate the gradient of the curve at 3.15, 3 and 1.5. 3 and 1.5, 3 on the x-axis and 1.5 on the y-axis. This point has to be somewhere around here. So I'm gonna, in order to calculate the gradient, we need to draw a straight tangent line across this point. So because I'm using this, because I'm using computer, I can adjust my line. So because you'll be using your rulers, you need to place your ruler so that you reach to maximum contact of this point 3 and 1.5. One point that I should be certain of on that is on the line is 3, 1.5, because that's the point where I made sure my line, my tangent passed through. So the other point could be 2 and 3.2, let's say. This is an estimated point, so I just took this point on the line. So it's 2 on the x-axis and then 3.2 on the y-axis, because there are 5 boxes representing 10 units, so one box is 2 units. So let me find out the gradient to, 3.2 minus 1.5 over 2 minus 3. So my gradient is -1.7. And if I check the marking scheme, it says negative 2.4 to negative 1.6 is accepted. So we have negative 1.7. It's accepted. It's in the acceptance range, so it's fine. Right. Moving on to the next part. The points of intersection of the graph this and the line y is equal to k are the solutions of this. Okay. Because we need to find the value of k, I need to replace y with k and take the LCM on the right side. So it's going to be 2, and on the numerator 6 plus 2x minus x square. Now there is a longer way also, but because we've got less space and it's a 1 mark, let's look for a shorter method. So by manipulating this equation, 2x minus x square should be equal to negative 10. I just moved this 10 to the other side. So I get the value of 2x minus x square, which is negative 10. So substituting this in the value of k gives me 6 plus, so instead of 2x minus x square, I'll be writing negative 10 and whole thing divided by 2. So 6 minus 10 is negative 4, and negative 4 divided by 2 gives you the value of k, which is negative 2. Alright, by drawing y is equal to k, which means y is equal to minus 2, we need to draw this on the graph, find the solution of this. Okay, so y is equal to 2, we need to plot y is equal to 2. So y2 is right here. And for the solutions, we need to see where this line, the blue line, this line is basically y is equal to 2. We need to see where this line cuts the curve. For the solution, we need to see where this line cuts the curve. So points of intersection are this one is first and this one is second. So I'm going to draw a smaller line touching the axes, so it's easier for you to look at the coordinates. So the coordinates of this point has to be 4.3 on the x-axis, because there's 10 boxes between 4 and 5, so 1 box is 1 unit. So it's 4.3 on the x-axis, and on the y-axis it has to be negative 2. Right? And the other point has to be this is 2.3, something like that, on the negative side. So I'll just write it down here. It's negative 2.3 and 2 on the y-axis. Okay, let's read the question again. Find the solutions. Okay, now whenever we're talking about the solutions, we just have to write the x-axis, I mean the x values. So the two values we are looking for are negative 2.3 and positive 4.3. And if we look at the marking scheme, It says negative 2.4 to negative 2.3 is the accepted region, so negative 2.3 is correct. And for the other value, it says 4.3 to 4.4, so it's fine. And the tolerance is plus minus 1 small square, so we're good. Now, next one is, this is a sketch of the graph y equals pa power x, where a is greater than 0. The graph passes through the point 0, 4 and 2, 36. Write down the value of p. So the value of p by just looking at the graph is 4. It's because of this. All right. Now for the value of a. So it says a is greater than 0. All right. Y equals p a power x. Let's take this point because it lies on the line. On the curve. So instead of y, I'm going to write 36. P, we already know it's 4. A to the power 2, right? So 36 divided by 2. Sorry, 36 divided by 4 is 9 equals a squared. And then the value of a will be 3. Ideally, it is plus minus 3, but because of this condition that a is greater than 0, we are going to reject the negative value and accept the positive value. So the value of a turns out to be 3. Okay, because a and b are constants, so we are supposed to use the same values of a and b, which are 4 and 3. So y equals to p a power x, right? And this is going to be my x and y. So instead of y, I'm going to put q. P is 4, a is 3, and x is power 4. So 3 power 4 is 81, and 81 times 4 is 324. Subscribe to my channel Octopus Math by Sahiba for more videos.